Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Troubleshooting is not just about fixing problems, it's about understanding them. Without a structured approach, technical teams risk making poor assumptions, wasting valuable time, and even introducing new problems while trying to resolve existing ones. This is where methodology becomes essential. A structured troubleshooting method provides clarity, consistency, and accountability. It allows IT professionals to approach problems logically and ensures that no steps are skipped during the diagnostic process. Whether you're responding to a critical outage or resolving a minor connectivity complaint, having a defined process keeps your efforts efficient and your results reliable. In this episode, we'll focus on the first half of the structured troubleshooting methodology: identifying the problem and establishing a theory of probable cause. These first two steps are the foundation for everything that follows. If you get these wrong, it doesn't matter how good your tools or technical knowledge are, your resolution will likely be ineffective. That's why this phase is often the most important for the Network Plus exam and for real-world operations. Understanding how to properly define a problem and form a logical theory is essential to every successful troubleshooting effort. The process begins with Step 1. Identify the problem. This step focuses on collecting as much relevant information as possible to clearly define what is happening, who is affected, and how the issue is presenting itself. This starts with gathering information directly from users. Whether they submit a help desk ticket, report a problem verbally, or describe an issue during a meeting, it's essential to document exactly what they're experiencing in their own words. Then, refer to documentation such as network diagrams, IP allocation tables, and recent change logs to identify any known configurations or pending changes that might relate to the issue. Monitoring tools, alert dashboards, and log aggregators also provide critical data points, allowing you to verify whether the reported issue is isolated or part of a broader pattern. Asking effective questions during this phase can make or break the identification process. Ask users when the issue began and whether it started suddenly or gradually. Determine who is affected: just one person, an entire department, or every remote office. Ask what tasks they're unable to complete and whether they've already tried any fixes on their own. Always ask what changed. Even seemingly unrelated changes to a firewall rule, patch update, or cabling reroute might be highly relevant. Good questioning uncovers hidden clues, helps eliminate red herrings, and gives the technician an understanding of the issue's timeline and scope. Next, it's time to check indicators and symptoms directly. Look at LED status indicators on switches, routers, and access points. Are the lights flashing normally, or is something dark or blinking irregularly? Review interface counters for errors, discards, or packet drops. These metrics can point directly to physical faults or congestion issues. Check logs from switches, firewalls, and endpoints. Any authentication failures, route changes, or port shutdowns can offer leads. Alerts from monitoring tools can confirm or contradict what users are reporting. By gathering both subjective input and objective data, you get a complete view of the issue from multiple angles. Verifying the problem's scope is a key part of defining its nature. If only one user is affected, the problem may be on their local device or cable. If several users in the same department are impacted, it could be a switch, access point, or VLAN issue. If users across different locations are experiencing the same symptoms, the problem may lie in the data center, cloud provider, or internet gateway. Determine whether the issue affects wired or wireless users, internal or external connectivity, or specific applications. This helps you narrow down the list of affected systems and avoid overgeneralizing the problem. Step 2 of the methodology is to establish a theory of probable cause. This is the point where you begin forming a hypothesis about what's likely going wrong based on the data you've collected. You don't need to be certain yet, you just need to identify the most likely explanation so you can test and validate it. This may involve considering environmental factors such as construction near cabling, recent software updates, or known hardware vulnerabilities. It's essential to build your theory on logic, not assumptions. A well-reasoned theory allows for efficient testing and reduces the chance of wasted effort or incorrect fixes. A core principle of establishing a theory is eliminating the obvious first. Before diving into advanced diagnostics, check the fundamentals. Is the user's cable unplugged? Has the network adapter been disabled? Is the correct IP address or VLAN assigned? Is a port turned off or blocked by a firewall rule? These simple issues are often overlooked, leading to longer resolution times and unnecessary escalations. Starting with the basics ensures that low-effort, high-probability causes are ruled out early in the process. Use logic to rank your theories. Which one is most likely to be true based on the evidence? Which one is the quickest to test without causing disruption? Which theory, if true, would impact the largest number of users or systems? By applying these logic filters, you create a prioritized list of potential causes that guide your next steps. This helps avoid guesswork, reduces troubleshooting time, and improves confidence in the process. Logical prioritization also supports better communication with peers, especially when you need to escalate the issue or hand it off to another team. In some cases, you may need to consider multiple theories simultaneously. Complex issues, such as intermittent outages or performance degradation, often have layered causes. A wireless connection may drop due to both environmental interference and misconfigured security settings. A user may experience DNS failures because of both local firewall blocks and upstream resolver issues. In such cases, collect more data before deciding on a single theory and be prepared to revisit your assumptions if the symptoms don't match your expectations. Troubleshooting is rarely linear, and flexibility is key. Throughout this process, documentation remains essential. Record everything, from the user's initial report to the results of your tests and any configuration changes made. Good documentation ensures that if the issue reoccurs, future technicians can pick up where you left off. It also helps when handing the problem off to another team or escalating it to higher-level support. Logging your findings builds institutional knowledge and supports audits, reviews, and team training efforts. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. The initial phase of troubleshooting, identifying the problem and establishing a theory of probable cause, is arguably the most important stage in the entire methodology. Everything else in the process builds on what you discover here. If you misidentify the issue or develop a flawed theory, every action you take afterward will be misaligned. You may spend time testing unaffected devices, adjusting unrelated settings, or replacing hardware that's functioning correctly. These missteps are costly not only in time and resources, but also in user trust. A technician who gets the diagnosis wrong is less likely to inspire confidence, and recurring issues will quickly erode that credibility. Taking the time to fully understand the issue before taking corrective action dramatically increases the chance of resolving it correctly on the first attempt. The certification exam will often present scenarios that test your ability to think like a troubleshooter during this early phase. You may be given a user complaint and asked to choose the best starting point for investigation. In other questions, you'll need to identify the most appropriate tool to confirm a suspected issue, perhaps using ping to verify connectivity, trace a route to identify routing problems, or interface statistics to detect errors. You might also be presented with a set of symptoms and asked which direction to investigate first. These questions are not about memorizing commands. They are about applying logic, eliminating guesses, and thinking methodically. Practice reading exam scenarios slowly, asking yourself, what would I check first in the real world? Several tools prove particularly useful during the identification and analysis stage. Ping remains one of the most fundamental diagnostic tools, quickly verifying whether a target device is reachable and how much latency exists. Traceroute helps map the path between source and destination, showing where delays or failures occur in the route. Interface statistics can reveal high error rates, link flapping, or dropped packets, helping confirm that a suspected port or cable is underperforming. Multimeters and tone generators are excellent for testing physical connections, especially in environments with large numbers of cables or patch panels. SNMP and syslog viewers give visibility into device behavior, offering logs and alerts that may contain clues missed in user reports. These tools allow you to gather evidence without disrupting the environment, forming a solid base for deeper troubleshooting steps. Recognizing traffic patterns and symptom distribution can help pinpoint the likely source of an issue. For example, if all users across a site are reporting total internet loss, the problem likely lies with a core switch, router, or upstream connection. If only one VLAN or subnet is affected, you may have a misconfigured DHCP scope, a broken trunk, or an ACL issue. Intermittent performance problems, especially those reported only in certain areas, may point to wireless signal interference, loose cabling, or thermal throttling on devices. Understanding how problems manifest across different scopes helps you determine whether you're dealing with a localized issue or something systemic. One of the biggest advantages of taking time to define the problem carefully is that it supports long-term improvements, not just short-term fixes. When technicians properly identify root causes, the knowledge gained from that event can be shared across teams and incorporated into future configurations. Maybe a DHCP server keeps running out of leases, or a firewall rule causes intermittent access problem. Addressing the core of these issues helps prevent them from recurring. Over time, this reduces help desk tickets, increases user satisfaction, and leads to more efficient, reliable infrastructure. Troubleshooting becomes not just about solving problems, but improving systems overall. Knowing when to involve others is an important part of being a responsible and effective troubleshooter. Large-scale outages, such as a backbone failure or data center power loss, often require a coordinated response involving multiple departments. Similarly, if your initial investigation reveals problems that exceed your access or expertise, such as a misbehaving router in a location managed by another team, it's time to escalate. Bringing in colleagues with specialized knowledge, vendor support, or administrative privileges can save time and prevent misconfigurations. Escalating responsibly means clearly documenting what you found, what you've tried, and what you suspect. This ensures a smooth transition and avoids wasted time from duplicated efforts. This early phase of troubleshooting is all about staying calm, thinking critically, and remaining methodical. Technicians who jump into fixes without fully understanding the problem may get lucky once or twice, but eventually they will miss something critical. You don't want to reset a router without checking whether it's receiving a configuration update. You don't want to replace a switch before verifying that the uplink port is actually active. Premature fixes can cause bigger issues, delay true resolution, and lead to service instability. Structured troubleshooting protects against these mistakes by encouraging a thoughtful, evidence-based approach. By this point in the process, you should have a clear understanding of the reported symptoms, objective evidence of the problem's behavior, and a list of probable causes ranked by likelihood and ease of testing. Your documentation should be up to date, and your escalation plan should be ready if needed. This sets the stage for the next step in the methodology: testing your theory to confirm whether your most likely cause is accurate. In the next episode, we'll cover how to perform safe and effective testing without introducing additional problems. We'll also explore how to isolate and confirm the root cause and prepare for implementing a fix. To summarize what we've covered so far, begin every troubleshooting process with information gathering, symptom validation, and scope analysis. Ask the right questions, check the right tools, and verify all assumptions. From there, form a theory of probable cause using logic, not guesswork. Rank your theories, eliminate the obvious, and stay open to multiple possibilities when symptoms are complex. Document everything and collaborate when needed. This structured start lays the groundwork for accurate, efficient, and sustainable troubleshooting success. Clear identification and careful analysis are the most important traits of effective troubleshooting. A technician who begins with curiosity, patience, and structure is far more likely to resolve problems completely and prevent them from returning. Whether you're taking the Network Plus exam or handling real-world service tickets, remember that troubleshooting starts with understanding, not with fixing. The best resolutions are built on the best diagnoses. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.